Okay. So today we're just gonna do a little experiment that might be mildly pointless because I think this is gonna be pretty case specific. And I don't have a lot of different cases to test this with. I just have one use case, but we will be testing the efficiency of wireless charging. So this is a wireless charging module from a Belkin wireless charger. This is the internal module. This is a wireless charging receiver module. There was like $1 on eBay. It has a micro USB, which is going to a micro USB breakout board. And I'm just going to solder on this cable, which is a USB cable. And then I will be plugging that into this, which this is a constant current USB load from AliExpress. And this is a USB multimeter. So this does volts and amps. I could pass it to my real multimeter, but then I would only see volts or amps one at a time. And this is just more convenient. We will also be using my bench power supply, which tells me the volts and amps that my load is drawing. So I'm just going to have to read that to you because there's no way I can get that on screen. So we'll set that to 5 volts, and I have a USB port installed on there because I was like, I know, when I build this, I'll put a USB port on there so I can just power USB loads with it. And then I blew something up because it was set to 11 volts, and I plugged in a USB load. Fortunately, it wasn't like a phone or anything. It was just a couple dollar 5 volt rated module that I installed a USB cable on the end. I have charged my phone with it before, so I'm very glad I have not blown up my phone. I don't charge my phone with it often, but I've done it once or twice. Yeah, so we're just going to have it set to 5 volts right now. We're going to set it to 5.1 volts, which I think is well within the USB spec. We're going to limit the current to 2.4 amps is the USB spec, but we might limit it to 3 amps. Or, yeah, let's do 3 amps. That's a little bit of extra current. So our power supply is set. We'll plug in our micro USB cable. USB, you always plug it in the wrong way. That's why USB-C is kind of nice. But it's also, I don't know, I have mixed feelings on USB-C. I don't think it's actually that much more durable than micro USB. I've not had great luck with the cables lasting very long. This is interesting. One of the wires have fallen off of the boost converter for my soldering iron. So, here, let me show you. This is a boost converter. It takes 12 volts and makes it 24 volts from my soldering iron because I have a universal, this is my soldering fume extractor that just puts the fumes back in the room because I'm too lazy to put it out the window. And it's cold out right now, so it's winter in the Northeast. So I have a universal 12 volt supply going in from this to this. These are a bunch of barrel jacks, 2.5 millimeters, I think. And this is going to everything on my workbench. And the output wire of the boost converter came undone, which is great. So we're just going to fix that just in this one shot because I'm not going to stop it recording. It's flathead, not a Phillips head. There we go. Connected. Now my soldering iron should actually work. There it goes. My bench power supply actually has its own 90 watt, 24 volt supply going into it. It has an external power supply, even though it is in and of itself a power supply, because it's more just a variable boost buck converter. So now my soldering iron is actually hot and melting solder. Sure wish I put that fume extractor out the window. No, I don't really care that much. It still blows away the fumes, and then they just disperse in the room, which is better than, like, you know, bringing them in. Would be best if it went out the window, but it's fine as it is. There we go. That's the USB port connected. I'm just gonna make sure my bench power supply did remember its settings, which is good. The reason I fried that thing was I had it set to 5 volts, and then I turned it on and turned it off again for some reason, and it didn't remember my settings. Put this so you can actually see it. Just try and get my adapter plugged in. I don't know if I can do that in one take. If I can't do it in one take, my screen's not running right now because my adapter's not plugged in. And I don't know if it'll let me do this all in one take. Adapter, plug in. Screen is on, but it's not rotated completely properly. Now it should be rotated completely properly. Sorry about my garbage tripod. There we go. Now I can actually see what you can see. Okay. Focus. There we go. So here's the screen. That'll have information on it. This will go in. This will go onto here. No, like metal shards. There's like plastic shards from like 3D printed stuff. This will turn on. This in standby. This pulls 0.05 amps, which is 1/4 of a watt at 5 volts. And it doesn't seem to be going any higher than that, which is odd. Oop, I think I saw it spike. There it goes. I assume this is trying to pull way too much. Let me tune that down. So right now it's pulling 2.13 watts, which is 0.42 amps. And this is doing 0.16 amps, and you can't see it at all because it's... So that's really terrible efficiency. It's like staggeringly terrible efficiency. As I move this around, it doesn't get much better. Yeah, right now it's pulling 0.5 amps, and this is pulling 1.9. Yeah, 1.9. Oh no, that's a 6. Sorry, it's upside down for me. And you can't see it because it's too bright, and my camera is garbage. I think that's a 6. It's hard reading upside down. So we increase the load. Now it's only pulling 0.05. Pulling 0.32 here. I move it. Oh, I guess I must have decreased it more. 0.51, 0.12, 0.64, 0.12. This is like really garbage efficiency. This is why wireless charging doesn't work well. .18, 0.51, 0.23, 0.58, and once I start getting higher, it starts crapping out. And before you start going, oh, that's the resistance of this cable. I don't think this cable is that high resistance. I can double check, but the wires are decently thick, and they're probably copper-clad aluminum. Like for USB, this is probably a pretty typical USB cable, and at 5 volts, it's not a lot of volts. I mean, and I know amps is more what affects this kind of thing, but not a lot of amps either. I don't know, Ohm's law, I haven't taken physics yet. I like know the basics of Ohm's law, like kind of. But Ohm's law, it's the voltage drop will depend on the number of amps and the resistance. And like, keep in mind that this is doing like half an amp. So this would have to be really high resistance. I can double check. I'm very skeptical that that'll change anything. I just want a USB break. I guess I can just try and stabby in there. Put my multimeter on beep mode. Oh no, why would I put it on beep mode? I want the resistance, not the... Okay, it's on resistance mode. Okay. Here we have the positive. Unplug you. Or not. This is still on, so I should probably turn this off. There we go. Okay, what are we talking about? 0.8 ohms. 0.8 ohms is the resistance across that cable. So, you know, losses in the cable should be negligible. Yeah, so wireless charging just has garbage efficiency. Or at least this wireless charging. This isn't like Samsung's fast wireless charging or anything. This is just a cheap Belkin, what's it called? Belkin QI charger, whatever they're called. It's just a cheap, like, standard Belkin wireless charger. And this is completely out of focus, but it's fine because there's nothing to look at. Focus. Yeah, so anyways. Focus. Anyway, so yeah, this is just a cheap Belkin, wireless charger, and this is just a cheap charging thing. So it might be better in certain cases, but this is not, like, this is why wireless charging is not a great technology, is basically the issue here. And I took this off because heat pipe gets in the way because I upgraded the heatsink. Not that I needed it for this case. Anyways, yeah, I don't know what really was the point of this, besides I've been meaning to check how garbage wireless charging is for a while, and now I've confirmed that it is, in fact, complete and utter garbage. And you see, this is rated at an amp. This didn't get anywhere near an amp. I think this Belkin might also be rated at an amp, because I don't think this is rated at 2 amps, but we did see about 50% efficiency. So, or even a little bit less. So if this Belkin has a 2.4 amp charger and we have a little bit less than 50% efficiency, then getting about an amp out would make sense. So I don't think my numbers are too far off. I'm sure there's other people who have numbers online. I just wanted to test it for myself. Because, I don't know, it seems like an interesting test. And I had all of the equipment required to do it. Stuff's falling off the desk, but it's fine. Yes. And this was all done in one take, so I can actually upload it. Because I have lots of, like, multiple take projects, but those can't be uploaded, because I actually need to edit those, and I really, really don't feel like doing that. Yeah. That's all. Bye.